Not Villarrica, not Lema, not even Calbuco, whose eruptions have filled newspapers and television screens for generations. The volcano that suddenly forced scientists across Chile to pay attention in the spring of 2026 was one that most people had never heard of. Its name is Nevado de Longaví. At first glance, there is nothing about the mountain that appears extraordinary. Rising 3,242 meters above sea level in Chile's Mall region, its snow-covered summit blends naturally into the countless peaks of the Andes. Travelers passing through the region see another beautiful mountain. Farmers living in the valleys below see a familiar part of the horizon. Even among Chileans, Longaví rarely enters conversation. And for good reason. Unlike Villarrica, which erupts regularly, or Calbuco, whose explosive awakening in 2015 sent ash thousands of meters into the atmosphere, Nevado de Longaví has remained silent for so long that human civilization itself has forgotten it. Its last confirmed eruption occurred roughly 6,600 years ago. 6,600 years. Those numbers are almost impossible to comprehend. When Longaví last produced lava and ash, mammoths had only recently disappeared from some parts of the world. The first cities of Mesopotamia had not yet risen. The Egyptian pyramids were still thousands of years in the future. Writing did not exist. Iron had not been discovered. Ancient Greece, Rome, China, and the civilizations of the Americas that would later flourish all belonged to a future unimaginably distant. Generation after generation lived and died beneath this mountain without ever seeing it move. Entire empires rose. Entire empires collapsed. Languages appeared and vanished. Religions spread across continents. Wars changed. No eyewitness accounts exist. No paintings. No oral traditions. Nothing. Humanity has absolutely no memory of what this volcano looks like when it wakes up. And then, in May of 2026, after more than 60 centuries of silence, the earth beneath it began to crack. The first signal appeared during the early hours of the morning. A volcano-tectonic earthquake. By itself, such an event would not have attracted much attention. Volcanoes around the world produce small earthquakes all the time. Many never erupt. Many remain restless for years before returning to dormancy. But something about Longaví was different. Within hours, the first earthquake was followed by another. Then another. Then dozens. Then hundreds. By the end of 2 days, more than 400 separate earthquakes had shaken the rocks beneath the volcano. Scientists from Chile's National Geology and Mining Service immediately recognized that they were observing something unusual. Not because earthquakes beneath volcanoes are rare, but because this particular volcano had been asleep for 6,000 years. No one had ever seen it behave this way. No one knew what came next. The southern volcanic zone of the Andes stretches for almost 2,000 kilometers through Chile and Argentina. More than 70 volcanoes within this region have erupted sometime during the last 11,000 years. Many of them are well understood. Scientists know their personalities. They know their warning signs. They know what seismic patterns usually precede eruptions. Villarrica, for example, has erupted repeatedly in modern history. Researchers have decades of observations. They understand how pressure builds inside its plumbing system. They understand its magma composition. They know what gas emissions increase before activity. But Longaví? No instrumental records. No previous crises. Everything scientists know about the volcano comes from ancient rocks and chemical analyses. And those analyses reveal something strange. Something that makes Longaví fundamentally different from many of its neighbors. Far out beneath the Pacific Ocean, hundreds of kilometers offshore, the Nazca Plate slowly dives beneath South America. This process, called subduction, occurs at roughly 40 millimeters every year. It sounds insignificant, but over millions of years, it has built the Andes themselves. As the oceanic plate descends into the mantle, minerals trapped inside the crust release water under tremendous temperatures and pressures. That water lowers the melting point of surrounding rocks. Magma forms, and volcanoes are born. It is a process repeated across much of the Pacific Ring of Fire. But beneath Longaví, something unusual appears to be happening. Researchers studying the chemistry of ancient lava discovered evidence pointing toward the influence of the Mocha fracture zone, a massive structure in the oceanic crust that carries unusually high amounts of water deep beneath South America. Imagine an enormous crack crossing the ocean floor. Over millions of years, seawater penetrates deep into that fractured rock. As the plate sinks into the mantle, all that trapped water is released. And directly above this process lies Nevado de Longavi. The additional water changes everything. It alters the chemistry of the magma. It increases gas content. And potentially, it creates conditions capable of generating explosive eruptions. Geochemists have described Longavi's magma as unusually water-rich, and Longavi's underground plumbing may be unlike almost anything else in the southern Andes. And that is exactly what makes the recent earthquake swarm so intriguing. The earthquakes themselves were not random. They repeatedly originated from nearly the same location, roughly 3 kilometers beneath the surface, about 4 to 5 kilometers from the summit crater. Again and again, rocks fractured inside that same underground region. To volcanologists, such patterns suggest stress, pressure, movement, something beneath the mountain attempting to find space. Perhaps hot fluids, perhaps volcanic gases, perhaps magma itself. Nobody knows. And that uncertainty is perhaps the most unsettling aspect of all. Because humanity has no experience with this volcano. There is no checklist, no historical precedent, no famous eruption to compare it with. The mountain exists outside recorded history. Scientists are effectively trying to understand a giant whose last words were spoken before civilization itself existed. Adding another complication is the snow and ice covering the summit. The name, Nevado, means snow-covered. And while Longavi's glacier is relatively modest compared with some Andean giants, it represents a serious hazard. Because volcanic eruptions do not only produce lava. Sometimes, the deadliest threat comes from water. If hot ash, pyroclastic flows, or even elevated temperatures melt snow and ice on the summit, the resulting water can mix with loose volcanic material and create massive mud flows known as lahar. The eruption itself was moderate, but the heat melted part of the summit glacier. Gigantic lahars raced down river valleys. Within hours, entire communities disappeared beneath mud and debris. More than 23,000 people lost their lives. Today, scientists are careful not to draw direct comparisons. Longavi is not Nevado del Ruiz. The current earthquake swarm does not guarantee an eruption. Many volcanic crises end quietly. Earthquakes decrease. Pressure dissipates. And life returns to normal. But every volcano writes its own story. And Longavi has not written a chapter in 6,000 years. Meanwhile, the valleys surrounding the mountain are far from empty. The Mall region is one of Chile's most productive agricultural areas. Vineyards stretch across the landscape. Fruit orchards support thousands of families. Timber industries, farms, and communities rely on rivers originating in the Andes. Millions of dollars in agriculture depend upon stable conditions. And beneath the snow-covered summit, instruments now listen constantly. Seismometers record every vibration. Satellites monitor tiny changes in ground elevation. Scientists analyze gases. Thermal cameras watch for unusual heat. Computers process information 24 hours a day. Because somewhere beneath 6 kilometers of ancient silence, something has changed. Not necessarily an eruption. Not necessarily danger. But change. And perhaps that is what makes Nevado de Longavi so fascinating. Human beings have witnessed the eruptions of Etna. They have documented Vesuvius. They have climbed Fuji. They have studied Krakatoa, Pinatubo, St. Helens, and countless other volcanoes. But Longavi belongs to another category entirely. It belongs to the forgotten volcanoes. Mountains so ancient and so quiet that civilization itself grew up around them, assuming they had become part of the landscape forever. Yet geology does not recognize human calendars. It does not care about civilizations. It does not remember history books. A volcano may sleep for 6,000 years, or 60,000, but sleeping is not the same thing as being dead. And now, for the first time since before the pyramids, before Rome, before writing itself, Nevado de Longavi is speaking again. The question scientists are trying to answer is deceptively simple. Is the mountain merely stretching in its sleep? Or are we witnessing the first whispers of an awakening that no human being has ever seen?